Okay, in these questions we're asked to find the values of the pronumerals giving reasons using the properties of the parallelogram that we looked at. So we know that we've got a parallelogram here. But firstly, we've got all these unknowns, E, F, G. The first thing that would be easiest to work out would be E, because that's a triangle. So we can go E plus 78 plus 45 is 180 degrees. Reason, angle, sum of triangle. And so therefore E is 180 minus 78 minus 45. And if you do that on your calculator, you get 57 degrees. Then, now that we know that E is 57, we've got a parallelogram. We have to think of all the properties of a parallelogram. And one property is that opposite angles of a parallelogram are equal. So F equals E, which equals 57 degrees. The reason opposite angles of the parallelogram are equal. And now for the last bit in this question, to work out G, we know that G plus F is 90, or we can just say that G equals 90 minus F, which is 90 minus 57, which is 33 degrees. And the reason that I'm writing that is that we've got complementary angles, or you could say angle sum of right angle. Okay, so that's the first question there. Done. Now for this second question here, now there are a few steps here that we need to do this question. Now what I'm going to do, I'm going to label all these corners A, B, C, D, and I'm just going to go E, F, all the vertices, okay? Now we can see here A, B, C, D, well that shape's got 4 equal sides, so A, B, C, D must be a rhombus. And we can, so I'm going to write that in a minute, and we can see that A, C, D, that looks like it's an equilateral triangle. So I'm going to start off with ACD is an equilateral triangle. Reason, it's got 3 equal sides. Okay, so therefore, if we know that ACD is equal, we know all the angles in an equilateral triangle are equal to 60 degrees. So therefore X, now I can say ACD, but I don't have to. I don't have to put angle ACD because there's an X in its spot. So therefore X is 180 divided by 3, which is 60 degrees, because angles in equilateral triangle are equal, all equal to each other. Okay, so I've worked that out. Now I've got to work out what Y is. Now, remember, we know that ABCD is a rhombus. And the reason that ABCD is a rhombus is that it's got 4 equal sides. Now we need to think of the properties of a rhombus. We know all 4 sides are equal, opposite sides parallel, opposite angles are equal, but girls, even though this looks like a square, it's not. They've purposefully drawn it not to scale, okay? So don't go putting that X is 45 and Y is 45. We've seen here that this is an equilateral triangle, so X is 60. Now, diagonals of a rhombus. This is a diagonal of a rhombus. So, and they happen to bisect the angles or the vertices of the rhombus. So Y is equal to X, which equals 60 degrees. And the reason is that the diagonals of a rhombus bisect the angles or bisect the vertices. Bisect the vertices or angles of the rhombus. Okay. So we've got that Y equals X, which is 60. In other words, this whole thing here would be 120. Now we need to work out Z. Now I'm going to outline where Z is. So I'm going to put a line down here, because otherwise it's hard to see, and a line here. And you see, when I do that, I can see that this angle is vertically opposite with that angle in pink. So now I can say that Z equals Y, which equals 60, reason, vertically opposite angles. Okay, that is a bit of a tricky one, also because it's not drawn to scale. Okay, So you really needed the properties of a triangle here, equilateral triangle. You also needed to know the properties of a rhombus, that the diagonals bisect the angles of the rhombus. Now for question 9. Now these questions are harder, but we're not asking you to give reasons for these ones. So let's look at this first one. Okay, here is question 9H. Now it says that STUV is a square. Now that tells us a few things, that we've got right angles. It also tells us that all the sides are equal in length. But we can also see, and this is the most critical thing in this question, because if you can't see it, you actually can't do it, that we've got the diagonal of a square. So it's really important in these questions to look at the diagonals. So we're going to start with that. We know that STUV is a square, so we're going to say that SU is a diagonal of the square. So therefore, angle TSU is equal to 45 degrees. That's because the diagonals of a square, sorry, this is moving, because the diagonals of a square bisect the angles of the square. Now, I could also put, before I start, that angle TSV is equal to all the other angles, is equal to 90 degrees as well, because angles in a rectangle are 90. But all the angles are 90 as well, okay? So I think I might need some other angles a bit later as well, but I'm just going to put that angle TSV is 90, and we know that angle TSU is 45 because the diagonals of a square bisect the angles or the vertices of the square. So we're nearly there for A, okay? We've nearly found A. We also know here that VW equals WU. That means that that's an isosceles triangle. But we also know that triangle SWT is equilateral, so SWT is equilateral. So I'm just going to write that because we know that SWT is equilateral, we know that all the angles are 60. So we've got 60, 60, 60. So that whole thing is 60, by the way. So angle TSW is equal to 60 degrees. And that is because the angles in an equilateral triangle SWT are all equal to 60 degrees. Actually, I don't need to write equal and equal, so equal 60 degrees, okay? So I'll just make this a bit bigger. So we've got that whole angle TSW is 60. So if the whole thing is 60, if I could draw it all, and that bit there is 45, therefore A will be 60 minus 45, which is 15 degrees, okay? Now remember, sorry, we didn't need to give reasons here, but I'm just giving the reasons anyway. So A is 15. Now, let's just look down here, if we can work out B. If we know that TSW is 60, and we know that TSV is a right angle, so if we've got a right angle here, and that shaded bit there is 60, then this other little bit in here is 30, because 30 and 60 make 90. So I'm going to go that angle VSW is 90 minus 60, which is 30, because again we know that we've got the right angle there. Okay, angles in right, complementary angles or angles in right angle. Okay, so that's 30. We really need to work out this one before we can work out B. Now we know that VW equals WU, so I can say that triangle VWU is an isosceles triangle, and so therefore angle WVU equals angle WUV, which is 180 minus 140 divided by 2, which is 20 degrees. So these angles here are 20 degrees, and that's 20 degrees, okay? Okay, reason for that would be base angles of isosceles triangle and angle sum of triangle. But, we don't have to put reasons for this one. Okay, we also know that here we've got a right angle, so therefore this will be 70. So angle SVW, sorry, angle SVW is 90 minus 20, which is 70. And that's by that's by angles in a right angle as well. And so therefore to work out B, we've got a triangle there. It's 180 minus 70 minus 30, which is 80. And if you had to put a reason, that would be angle sum of triangle SVW. Okay? All right. So with these, you don't really have to put the reasons for these because it's quite long and complicated. Let's look at the next question, I. It says that ABCD is a rhombus, ABCD is a rhombus, and BEC is equilateral, and you have to work out little a and this B here. Okay, right. Well, let's just put some markings on it. I think that will help us. Now, if ABCD is a rhombus, it means that the four sides are equal. And if BCE is an equilateral triangle, then this side equals that one, which equals that one. So in other words, all those lengths are equal, okay? Now, let's see. Looks like we've got an equilateral triangle here again. So what I'm going to do, this is equilateral, this triangle here in pink. So I'm going to put all our 60-degree angles. That's 60. So that means that that angle up there where A is 60 as well. So A is 60. Okay? So we can write that one down, that A is 60. Okay? So I've outlined that equilateral triangle in pink. Now, unless you put the markings there and the markings here, so once you know that these are all equal, because these other two equal that, and that's got a single dash, whatever length it is, the other two are the same, which makes this equilateral, which makes this angle in here, angle A, equal to 60 degrees. Okay, you don't have to give reasons. The reasons would be that it's an equilateral triangle and all angles in the equilateral triangle are 60 degrees. So we've got 60 in there, 60 there. We know this whole thing is 60, but we still have to work out this. We know that that's 32. We have to work out some of these other angles. Now, also, if this angle in here is 32, look, I've got triangle ABE. I'm just going to write that one down. ABE is an isosceles triangle. The reason is because AB equals BE. So that means that that little 32-degree angle down here, and I've done it in pink, is equal to this angle up here. That's also 32 in there. Okay? Now, I still do need to work out a B here. Okay? So I've got that angle BAE is equal to angle BEA, which is 32 degrees. It's because triangle ABE is isosceles. Now, if I look at triangle ABE, I know that this side here is 60, but I can work out that whole thing because angle ABE, this top one in that triangle, I'm actually going to draw that triangle like this so that you can see it. This is what I've got, B, E, and this is A. That's 32, that's 32. I can work out that whole angle there. Angle ABE is 180 minus 32 minus another 32, so it's 180 minus 64, which will be 116 degrees, but that's the whole of ABE. Now we know that part of that angle in there is 60, so therefore angle ABC, this one in here, so if ABE is 116, ABC will be 116 minus 60. So I know that whole thing is 116, but if I put my line down here, I know that this bit in here is 60, so therefore this bit here with the dot, which is what I'm doing now, is 116 minus 60, which is 56 degrees. So this bit in here is 56 degrees. Now that I know that that's 56, and this is a rhombus, opposite sides of a rhombus are parallel, so therefore B plus 56 is 180 degrees. Remember, they're co-interior angles, okay? So therefore B will be 180 minus 56, which is 124, I think. Now, if you were to put a reason for that, you would go co-interior angles. AB is parallel to DC. Okay, they're parallel. AB is parallel to DC. Okay, and you could also say, yeah, because we know that opposite sides of a rhombus are parallel as well. Okay. Now, this question is quite tricky, okay? And you could be asked like something like this towards the end of a paper, definitely a level 5 question, where you're combining properties of, say, equilateral triangles, isosceles triangles, properties of a rhombus, so you really do need to know your properties. Okay, now question 10 says find the value of the pronumerals giving reasons. Now, again, we've got a rhombus. So if this angle here is 66, we know that the angle down there will also be 66, but remember with a rhombus, we've got a diagonal. You have to think of everything about the diagonals of a rhombus. Will they bisect each other? But they do bisect each other at right angles. Also, so that's a really important thing. And the other thing with diagonals of a rhombus is that they bisect the angles of the rhombus. So each of those dots there are 33 degrees, okay? So remember, we're still here trying to find x, we're still trying to find this value of x, but we do know that that's a right angle, and so will all of these. They're all right angles, so that might help us. Remember, we've got alternate angles as well, okay? So we might be able to do something there, okay? All right, let's start. So if we look at x, it's alternate. I'll just put a double mark there. It's alternate with that one. So if we can work out this angle here, this one, it'll be the same as what x is, because they are alternate angles on parallel lines. So why don't we try and work out what this angle is? Okay, now we know that this whole thing is 66, and we know that opposite sides of a parallelogram, of a rhombus, are parallel. So I'm going to say, well, PS is parallel to QR because they are opposite sides of a rhombus. And I know that that whole angle PQR is 66, so therefore angle SPQ is 180 minus 66, which happens to be 114. Reason, co-interior angles. PS is parallel to QR. So here we've got co-interior angles. If that's 66, that whole thing is 114. So this whole angle is 114, the whole thing. Okay, but we know that, again, diagonals of a rhombus bisect the angles or the vertices of a rhombus. So angle QPT, so this angle here, QPT, this one just there, is equal to a half of 114. So it's 114 divided by 2, which is, I think it's 57 degrees. Okay, so it's 57 degrees, that angle marked there. Now, so therefore x is equal to angle QPT, which equals 57, because see, we've got our alternate angles. Reason, they are alternate angles, and we're told that UV is parallel to PQ. Okay, so again, you know it's a rhombus. If you need to say anything about parallel, you need to state which parallel lines you're using. So PS is parallel to QR. So if that's 60, this is 114. Look, this question could have been done another way as well. There's a couple of ways you could have done it. If you can't think of that way, remember at the beginning of the question I was saying, well, if that's 66, this is cut in half, that would be 33, right? Then you could have said, well, these are diagonals of a rhombus. They bisect at right angles. That's 90 in there. That's a right angle. And then you could have also then done, so you could have done that angle PQT is 66 divided by 2, which is 33. Again, reason, diagonals. Sorry, I forgot to put the reason up here too. This is diagonals of rhombus bisect the angles of the rhombus, or bisect the vertices of the rhombus. Okay, same with this one. We could have done angle PQT is 33 degrees because the diagonals bisect the angles of the rhombus. Then I could have done that angle PTQ is 90 degrees because diagonals of rhombus bisect at 90 degrees. Then I could have done that this angle in here, could have worked it out, this little one here is 57 by angle sum of triangle. So angle QPT is 180 minus 90 minus 33, which is 57 by the angle sum of triangle. And then you would do the alternate angles like we did up there. And therefore X is angle, same as angle QPT, which is 57 alternate angles. Again, the parallel lines, UV is parallel to PQ. Okay, so look, there is not just one way to do these questions. You know, no one's particular way is correct. As long as you're putting all the reasons in, then it's okay. All right, the next question down here, which is question J. Look, we've got a square here. So we know all the angles are right angles. I'm just going to put those in. And we've got a parallelogram. So we know that opposite sides are equal, opposite angles are equal, and it looks like that one's going to be the one that's going to help us out here. So if this is 14 there, then so is this one, and then we can work out X. That one's actually a lot easier to do than the others. So I'm going to go that angle KLP is equal to angle KNP, which is equal to 14 degrees. Why are we saying that that equals that, which is 14? Because they are the opposite angles of parallelogram. Are equal, or just equal. Opposite angles of parallelogram are equal. Now, so we've used some information from that. That's 14, okay? We also know that angle KJM equals 90 degrees because it is angles in a square is 90, okay? So therefore X is just 90 minus 14, which is 76. Reason, angle sum of right angle, complementary angles, anything like that, okay? So that one actually wasn't too bad. Okay, now for K. Okay, again, we've got a rhombus. Just think of all the things you know. Opposite angles equal. Diagonals bisect the angles of the rhombus, so that is really, really important. Now, I know that 84 is sitting here, but it is the whole angle that is 84. So, and if this whole thing's 84, so's that whole thing. It's also 84. And so we know that CDEF is a rhombus, and we know that GH is parallel to FD. You have to try and find this angle here. Okay, oh, again, this is also a diagonal. So this diagonal will bisect these angles in half as well. So you might want to pause and try this all on your own. Okay, I think you can do it. And you've also got co-interior angles. Okay, so if we can work out the size of this angle, then we can work out the size of that one. So I wouldn't be working out this, all right? I'd be working out the size of this one first, this big angle here first, and then you know that this halves that angle, and then you've got corresponding angles. Okay, so pause the video, restart when you're ready. So we can say that angle CDE plus 84, so that plus the 84 is 180. Reason, it's co-interior angles, and CD is parallel to FE. Now, if you're not sure which lines are parallel, co-interior are like those C angles, and I can do a backward like C, okay? And you can also say, yeah, CD is parallel to FE. We've said that because they're opposite sides of, because opposite sides of a rhombus are parallel. So I'm just going to put that as well. Opposite sides of rhombus are parallel. So therefore, there's my backwards C. So CDE, this angle in here, plus the 84 is equal to 180. Therefore, angle CDE is 180 minus 84, which is 96. Now, we know that DF bisects angle CDE. So angle CDF is equal to angle EDF, which is 96 divided by 2, which is 48 degrees. Reason that DF, or I'm actually just going to put diagonals of the rhombus, diagonals of rhombus bisect the angles, bisect the vertices. So bisect the vertices, okay? So each of these two angles is 48, okay? Sorry, you can't see that very well. That's 48 and that's 48. And now that we know that that angle there is 48, this one also is, because they're corresponding angles on parallel lines. So X is equal to 48 degrees. Reason, corresponding angles. And I've got GH is parallel to DF. Okay, so you actually might want to go X equals angle CDF, which equals 48. Okay, so X equals angle CDF, so that X equals this angle CDF, because there are two 48s and we don't want them to get, you don't want to be confused about which ones you're talking about. So that equals that. Reason, corresponding angles. GH is parallel to DF. Remember, if you don't put the parallel lines down, you won't get the mark for that. Okay, so that one's done. And now for the last question. It says that QRSL is a rectangle. So we know a few things there. Main thing probably is going to be that these are right angles. Okay? And we'll mention that in a minute. And we also know that ML equals MN, which means that this is MNL is an isosceles triangle. Okay? Now this S is for that point, that corner. It's not the size of the angle. And here you have to work out the size of X down here. Okay? Now, what you can do first is this angle here, 36, equals that one there. So we've got angle MLN is equal to 36 degrees. Reason, base angles of isosceles triangle MLN. Okay, so we've got that angle in there is 36. So that's good. Okay, we've also here, remember we've got parallel lines. So we've got parallel lines here. So we've got alternate angles. I could actually work out that angle down there. So angle PNL is equal to angle MLN, which is 36. Reason, alternate angles, ML is parallel to NP. So now we've also worked out this angle down here. So we've done that angle because it's an isosceles triangle up here. Really important. We've done alternate angles because we've got parallel lines. We know that this angle up here is a right angle because QRSL is a right angle. So we can say that as well. So angle QLS, QLSR is a rectangle. So angle QLS is 90 degrees. It's just the angle in a rectangle. So that's a right angle. And so therefore this missing angle down here, X, is 180 minus 90 minus 36. Reason, it's the angle sum of this big triangle here of triangle PLN. So working that out, I think you get 54 degrees. Okay? All right, that's the end of that sheet. Now I know some of those are quite tricky, but unless you know the properties of if you know the properties of your quadrilaterals, it will be easier. Some of these are challenge type questions. You know, some of them are pretty tricky, but you've just got to really know your properties of your quadrilaterals to be able to do these.